Okay, now that we're done with the basics of static or IP static routing, let's go ahead and see configuring IP static routes on this section. Okay, so let's talk about the IPv4 next hop static route. So the commands to configure the standard static routes vary slightly between IPv4 and IPv6. So this topic shows how to configure the standard next hop, directly connected, and the fully specified static routes for both IPv4 and IPv6. Okay. Now, in a next hop static route, only the next hop IP address is specified. The exit interface is derived from the next hop. For example, 3 next hop IPv4 static routes are configured on R1 using the IP address of the next hop of R2. Okay? Now, referring to the topology that we have earlier, okay? So if I am on R1, the first thing that you need to do is to identify the directly connected networks to R1. Okay? And from here, the directly connected networks from R1 would be the 3.0 here and the 2.0 of 172.16. Okay? So identifying the directly connected networks will leave 172.16.1.0, 192.168.1.0, and 192.168.2.0 be the remote networks. Now, in configuring the IP static routing, we care only about the remote networks. So when we define it, we defined the remote networks. So if you will observe on this configuration here for R1, the remote networks would be 172.16.1.0. Okay, so which is this network here. All right. So to define it, so it should be IP route 172.16.1.0. That's slash 24. So that would be 255.255.255.0. Now the next one would be the next hop IP address. So if I am from, let me change my pointer here. So if I am from R1, okay, this is me, the next hop IP address to reach the remote network is this. All right, and that is 172.16.2.2. That's why you'll have it here. All right, so to reach 172.16.1.0, 192.168.1.0, and 192.168.2.0, you need to pass through 172.16.2.2 as the next hop IP address. So all of this here would be the next hop IP address of the remote networks. So that is why on the configuration, you're gonna have here IP route 172.16.1.0, subnet mask, which is 255.255.255.0, and you're gonna have here the exit interface. All right. So same thing with the second remote network, which is IP route 192.168.1.0. So you've got 255.255.255.0 via 172.16.2.2. So the third remote network is 192.168.2.0 here. So defining it on R1, that would be IP route 192.168.2.0, 255.255.255.0 via the next hop IP address, which is 172.16.2.2. All right. Now, after the configuration, so you might want to check the entry, okay, or the routing table entries on R1, and that would be possible via show IP route. Okay, or you could have the option or the more specific show IP route pipeline begin gateway. So that means that would start with the word gateway here. Now from the routing table, we could see that the remote networks that we have defined here is denoted by S on the routing table. All right, so you've got 1.0, 192.168.1.0, and 192.168.2.0. These three here are the remote networks that we defined on the configuration using IP route. All right. So aside from the directly connected networks, which is automatically detected by R1, since we already have defined the remote networks using IP route. So we can see here all the remote networks and the directly connected networks to R1. All right. Okay, so how about the IPv6 next hop static route? So it works the same with that of IPv4. Okay, so again, considering this topology here, so the commands to configure R1 with the IPv6 static routes to the three remote networks are as follows. So again, we have to identify. So we are from R1. This is where we're going to configure the IP route. We first need to identify the remote networks. And the remote networks would be, this is your first remote network, your second remote network, and your third remote network. All right. So when we define it, so in IPv6, we have to use IPv6 unicast routing. So every time you configure a router for IPv6, so you need to start or initialize IPv6 unicast routing. Don't forget this, otherwise you won't be able to configure any IPv6 configuration commands on a router. Okay, so we need to start or to begin with IPv6 unicast routing. So afterwards, we can now do the routing. Now, assuming that we have already configured all the IP addresses on each of the interfaces with IPv6, we can now proceed with routing. All right, so the syntax, which was shown earlier, would be IPv6, all right, and then route. This is your remote network, which is 2001 DB8 ACAD 1/64. Okay, so that's on R1, right? Okay, so this is the first remote network, and still this is our exit interface. Okay, so therefore, from R1 to reach 172.16.1.0/24, we need to pass through 2001 DB8 ACAD 2. Right? So this would be our exit interface. If you will observe, that is common to all the remote networks. Okay, so we need to pass through this to reach remote networks 1, 2, and 3. Okay, now let us define the second network. So that would be IPv6 route 2001 DB8 cafe :1::/64 via 2001 DB8 ACAD 2. Right, that 2. And then let us define also the last one, which is the third remote network from R1. So that would be IPv6 route 2001 DB8 cafe 2, okay, ::/64, traversing via 2001 DB8 ACAD 2, ::2. Okay, so after defining this route, so you might want to visit the routing table. So the command would be show IPv6 routes. And if you will observe here, we already have seen the three remote networks we just recently defined using the IPv6 route command. All right. Okay, so next would be the IPv4 directly connected static route. Okay, so when configuring a static route, another option is to use the exit interface to specify the next hop address. So the figure shows the topology again that we used on the demonstration. All right, so the IPv4 routing table for R1 shows that when a packet is destined for 192.168.2.0 network, which is denoted by S here, right? So this means this is a remote network. Okay, so R1 looks for a match in the routing table and finds that it can forward a packet out of serial 010 interface. So take note that this is your exit interface here. Okay, note that using a next hop address is generally recommended. Okay, what we did earlier, we use the next hop IP address instead of the exit interface. All right. So take note. This is a very important note here. So using the next hop address is generally recommended. Directly connected static routes should only be used with a point-to-point serial interfaces, as in this example. So take note that we can use exit interface here because we only have point-to-point connection here. Okay? Whenever we connected routers using the serial interfaces, we could make use of the exit interface. All right? Now, let us evaluate this. This is the same configurations that we made using the next hop IP address. The only difference is, with this one, we use the exit interface. All right? So, how are we going to use this? Where is the exit interface? Okay? If I am referring to R1, for instance, we are viewing it in a perspective of R1. Okay? So, 192 or 172.16.2.2 here would be our next hop IP address. And when you say exit interface, we are pertaining to this. All right? So, from the perspective of R1, we can leave the networks of R1 via serial 010 here. So that is why in here, you've got serial 010. Now, to reach the remote networks like 172.16.1.0, okay, we need to use serial 010 as the exit interface. Same thing, to reach the remote networks 192.168.1.0, right, we have to use also the serial 010 as the exit interface. That also applies to remote networks 192.168.2.0 using the serial 010 exit interface. All right. So again, this is the second method of defining static IP routing. So it's either you use the next hop IP address or the exit interface. But the use of the exit interface is applicable only when you are using serial connections between these routers. All right. Or when you have a point-to-point connection only between the two routers. All right. All right. So now you might be asking, is that also applicable on IPv6? Yes. Okay. So the IPv6 routing table for R1, okay, in the example, okay, shows that when a packet is destined for 2001 CAFE 2/64, so this is the S here, this is what we're pertaining to, okay. So R1 looks for a match in the routing table and finds that it can forward the packet out of the serial 010 here, which is denoted by directly connected, this one. Okay, so take note, same with IPv4, using the next hop IP address is generally recommended. Directly connected static routes should only be used only when you use the point-to-point connection or when you use serial interfaces between two routers. Okay, so it's the same thing. So IPv6 route, this is your remote network 1, okay, and this is our exit interface here. So remote network 2, all right, and then the exit interface, and then remote network 3, and then the exit interface. All right. Okay, so the third one would be IPv4 fully specified static route. So in a fully specified static route, both the exit interface and the next hop IP address are specified. So this form of static route is used when the exit interface is a multi-access interface and it is necessary to explicitly identify the next hop. So the next hop must be directly connected to the specified exit interface. So using an exit interface is optional. However, it is necessary to use the next hop address. All right. So suppose that the network link between R1 and R2 is an Ethernet link, and that the Giga Ethernet 001 interface of R1 is connected to the network as shown in the figure here. Okay. The difference between an Ethernet multi-access network and a point-to-point serial network is that a point-to-point serial network has only one other device on the network. Okay, so this is a point-to-point serial network here. And this one here, okay, so this is the Ethernet link. Okay, so with the Ethernet networks, there may be different devices sharing the same multi-access network, including hosts or even multiple routers. So it is recommended that when the exit interface is an Ethernet network, okay, so that the static route includes a next hop address. You can also use a fully specified static route that includes both the exit interface and the next hop address. All right. Okay, so in a fully specified IPv6 route, both the exit interface and the next hop IPv6 address are specified. Okay, so there is a situation in IPv6 when a fully specified static route must be used. So if the IPv6 static route uses an IPv6 link local address as the next hop address, we use a fully specified static route. Okay, so the figure shows an example of a fully specified IPv6 static route using an IPv6 link local address as the next hop address. Now in the example, a fully specified static route is configured using a link local address of R2 as the next hop address. So notice that the iOS requires an exit interface be specified. Okay, so this is how we do it. Okay, so IPv6 route, right? Same command. This is our remote network. This would be your exit interface, and this would be your next hop IP address. So you specified both the exit interface and the next hop IP address. This is known as the fully specified static route. Okay, so the first one also, okay, so IP route, remote network, okay, this is your exit or the next hop IP address, right? So this is the traditional way of doing it. But with a fully specified, this is another option. Okay. Now going back to the IPv4 here, how is it done? Same thing. So IP route, this would be our remote networks, all right? So with R1 being our source or the perspective of R1, you've got the subnet mask here. Okay, take a look at this. This would be your exit interface. All right, and you have here your next hop IP address. All right, so this is a fully specified static route. Okay, so the reason a fully specified static route must be used is because IPv6 link local address are not contained in the IPv6 routing table. Okay, so link local addresses are only unique on a given link or network. So the next hop link local address may be valid address on multiple networks connected to the router. So therefore, it is necessary that the exit interface be included. Okay. Now in here, the following example shows the IPv6 routing table entry for this route. So notice that both the next hop link local address and the exit interface are included. Okay, so this is your next hop address and this is your exit interface. So that means to reach 2001 TV8 ACAD1::/64, we can reach it via, okay, the next hop IP address here and the serial 010 here as the exit interface. All right, so that's it. Next, how do we verify a static route? So along with the show IP route, show IPv6 route, okay, ping, and trace route, other useful command to verify static routes also includes show IP route static. Okay, you also have the show IP route network, show running config, okay, pipeline section IP route, okay, and for IPv6, we just need to replace IP with IPv6. Okay, and that will work the same. All right, so verifying a static route. So again, using the topology that we have earlier. Okay, so display only IPv4 static route. So this output shows only the IPv4 static routes in the routing table. Also note where the filter begins the output. Okay, excluding all the codes. So something like show IP route static. Okay, pipeline begin gateway. So that means your output would start with your configuration gateway, right? And this would be the static routes configured. All right. Next, how about displaying a specific IPv4 network? So you can also do that. You can filter the output. Okay. So this command will show output for only the specified network in the routing table. So you specify the network to be 192.168.2.1. Okay. So that would be show IP route 192.168.2.1. So that would display routing entry for 2.0, and this is it. Okay, so known via static, the administrative distance is 1. Take note that the AD for the static route is 1, and the metric is 0. All right. Next, how about displaying the IPv4 static route configuration? Okay, section IP route here. So with this one, this command filters the running configuration for only IPv4 static routes. Okay, so show running config pipeline section IP route. So all configurations on the show run or on the running config having the IP route would be displayed. Okay, so rather than using just the show run, we displays everything. So if you just want to see on your screen a specific output that you desire, then you could make use of this filter options here, the pipeline, section, begin, and so on. All right. Next, display only IPv6 static routes. So that would be show IPv6 route static. This output shows only the IPv6 static routes in the routing table. Also note where the filter begins the output, excluding all the codes. All right. So show IP route static. Next, how about displaying a specific IPv6 network? So for instance, show IPv6 route 2001 DB8 cafe :2::. So this command will show output for only those specified network in the routing table. Similar with that of IPv4 that we have presented earlier. Next would be displaying the IPv6 static route configuration. So something like section IPv6 route. So that would be displayed on your screen. So see, you have a filtered output for your show run commands.